Okay. So this was one example that I had. This is. So we have in this example, and this example was from actually from the forums from Rhino. So I mentioned before, if like when we subdivide a surface, the subdivision goes from left to right or right to left on like the indexes. You can reorder that on how that is is created. So you could actually reorder it. So instead of going from left to right, it could go up and down. So an example of that is, in this particular example, they had, these points, these spiraling points. And right now they have this curve that follows these points in a certain order. What if you don't want those points to go in that order? You want those points to go up and down instead of spiraling upwards. So what you can do is you use this command called PathMapper. Now, unfortunately, there is a great plugin called TreeSloth that is that I've used before. That's really nice. Unfortunately, that's only offered for Rhino 4 and 5, not for 6. So we would have to use a PathMapper. And what a PathMapper does, so remember when we put our index here, what it's saying, and we have this order, essentially what PathMapper does is it rearranges that order for us and moves the element and the index, I believe, and it shifts it around. So if we take our interpret curve and we plug it into here, and we plug it through a new interpret curve, or I'm sorry, we take our divide points, and we're just going to turn this off, and we reorganize those points and plug it into our, they go up and down. So to be honest, I'm not too familiar with PathMapper. I've not used it that often. All I know is I've used it in these instances where we have to do it. It's not too often I do it that way, but it's essentially what it's doing, and you can search this as actually it flips the matrix of all the points of how they're organized. So even if we did our tree, where we had 150 branches, what's it? Now it flips it. So there's probably 150 entries, but within each one there's like 200, and so now this makes it 200 with 150 entries. So if you're having trouble with it, I would look towards this if you want to have a different way of how that your surface is reorganized. And if not, there's definitely components that are useless, and that was one thing I've been trying to find before class. Was there is a plugin that I use quite a bit that you don't have to flip this with a path mapper. It actually is just a very simple component that can do it. But just to give you a heads up though, there are ways that you can start to change how you reorder this. Reorder how we start to create these trees. So, okay, that was kind of what I had. But does anyone have any questions about their project? Everyone's making good progress.
I got some questions.
Okay, yeah, go ahead.
I'll share my screen. Share. Is it popping up?
Yeah, now I see it.
Okay. So I finally got it on there, which is awesome.
Nice.
And oops. I was curious how to use the cull feature in here to alternate two modules that I have. I couldn't quite figure out how to get, hold on, let me find the, going back and forth between CAD and Rhino, my fingers get all fumbled up. Okay, so during the help session, you showed me this nifty stuff here, and I was just curious how I can integrate that into this script I wrote. I'm using geometries instead of surfaces and points. I'm not quite sure how to get this to work with this surface script.
Okay, so you have your all right, so you took your surface, you subdivided it, and then you took your center point surface, and you took your evaluate surface, and you got, mind if I add?
Yeah. Go for it.
Because it's a little, it's like, it's always a little slow when you share because it's like you're remoting in to remote in. It's like an inception, like it's a dream within a dream.
I'm struggling today too, so I apologize.
No, you're good. You're good. All right, so for you, let's see, frame. So we took our frame. And then so you took the geometries, I'm assuming is your shape, your module.
Yeah, I just combined the whole thing. Ended up being the easiest thing to do, or at least the fastest.
Okay. And then you, based off that UV, you placed it on there. So what you want is your point should be the point here. Well, let's see. Let's see if the division points, because that's kind of where I believe it should be here, because this is where because essentially you're going to get Yeah, because you're pretty much, the points are the thing that drive everything
Yeah.
in your script. So that's where the call really needs to start to, yeah, that's where it starts to work out. So you would pretty much need to copy all this over. You bring that down because now you need this script for like the left side, and then you need this one for the right side.
Yeah.
So, and you need to split the point since everything is coming from that point. So if we put that point through here, and then we feed this back in here,
Okay.
and then we put this one in through here, and we feed it into here. Now you might not need to, like this one's grafted, so we might not need to graft it. We'll see how it behaves.
Okay.
If that did anything, that's one. So it looks like we split it. We just gotta make sure it goes in the right. It looks like they're just, well, now you can actually just take your geometry now.
Yeah, I need to change the geometry. Yeah.
Right, you can reference that.
Okay, cool. That makes a lot more sense.
So
I was just stuck on the surface. I don't know why. I should have just taken it away.
no, you're remember, like the call stuff, it doesn't matter when when it's like a call or anything that deals with just data trees, like where is it? Anything in the math sets,
Mhm.
it doesn't matter, it doesn't matter if it's a point, line, surface, vector, geometry. At the end of the day, it's just data and sets. That's all it cares about, is that it's data. It could just be a number, that's where it's able to deal with it. For a long time, for some of our, like the evaluate surface, it's only looking for a surface. It's really only looking for, a point or a domain. When it comes down to like lists, see, it's just blank. That hexagon is.
Yeah.
It doesn't matter. Any data works within this. So.
Okay, cool.
Yeah, no problem. But that should at least give you some control over it.
Right on. Thank you.
Yeah, no problem.
That's all I had.
Okay. How's the 3D printing going?
For me,
Yeah.
I did those few, and then I haven't really done much since then. I've just been trying to get it on the side of the building. But the actual module hasn't changed much from that original 3D print I did. So I feel good about the 3D print. I'm not so worried about that as I was about the getting it on the building.
Okay.
So I haven't done another one in a week or so.
Okay. Just keep in mind on just how these are going to be connected, and just
Yeah.
and how just some of the details that we can start to incorporate it onto this and like further develop this.
Do you actually have like, or maybe you've shown from some of your work examples, like an actual example of what you're looking for that connection mechanism, like how detailed in the 3D print?
As long as it's as long as it's a concept that's like that's thought out. I'm not looking at like every nut and screw is figured out. I'm more of looking for, okay, this is going to be a connection where we'll have a sphere, like more like a space frame connection where we'll have a sphere and we'll have like 6 members that will intersect into this sphere and that will hold everything together. Or it becomes more of a bracket design. Maybe we create this bracket that holds a couple members together.
Yeah.
Stuff like that.
Is there any building that pops in your mind? Eric brought up a good point of like fibers, like the fibers in palm trees. Is there any type of like building that pops in your mind that has some sort of connection mechanism like fibers that I could look to as inspiration?
Let me this, for some reason, this popped in my mind. Sure. Oops. Hold on. Sorry.
Okay. Do I need to stop share?
Yeah. Let me, yeah. Share. This just popped in my mind. I'm not sure if this is a good detail or not. But this is Rem Koolhaas did this, and I don't think this is like an example because it looks like, I mean, he had all these pipes and the pipes were eroded away. But they were all, well, maybe this, could help create a panel or something, but they were all just, it was all just formed into one solid piece. So it may look like a whole bunch of individual pieces, but they're all extruded along like a solid substrate to it, and welded to it. Yeah. So keep looking, but also look into like the actual, like how those strands work. Like if it's tightly woven, maybe the bird's nest, that's detailed out. Maybe we can get inspiration from this, that it's
I'll just go grab a piece of a palm tree and then just model it, take a picture of it, model it, and
and it doesn't it doesn't have to be highly deep, like I think
that's what I'm kind of stuck on, because like you think of fibers like that and they're really fine and detailed.
Right. The simplest one is when you deal with these parametric facades. It's this, no matter how complex it is, it's the same detail over and over again.
Yeah.
It's just it's just one thing is pivoted towards the other. It's a very flexible facade.
I guess I'm just worried how it would 3D print it.
Right. So if that's the thing is, 3D printing, maybe it's a detail that's not 3D printing. Maybe it's something that you 3D print 2 parts together and you have a bolt or something to help explain it.
Okay.
Maybe it's a series of elements, like, I think I'm trying to find it on my desktop, but maybe I have it in here. There's in one of the examples I posted it up on our assignment. Oh God, can I remember where that there's a good example of how this was. But actually, there's the very beginning of the semester, I believe I showed a example. No, that is not it. Gosh, what is it? Oh, I'm in the wrong spot. Here we go. So this was this airport in Mexico City that's no longer happening.
Why is it no longer happening? I'm just curious.
What's that?
Why is it no longer happening? I'm just curious.
Because it was going to cost the citizens of Mexico X. I don't know how much it was, but it was going to increase all their taxes a lot to build this, and so and Mexico at the time was not doing very well economically, so they had to increase all the taxes, so that left it up to a public vote, and the people said no to it, so it killed the project. They couldn't get the funds for it. But this,
I can look at this for sure. That looks like a good example.
but the one thing I really liked about this example, when this was actually a structural engineer in Europe, he did this presentation. So this is kind of where schematically we're at, right? It's just this lattice that's following down. That's it's just a concept, right? It's not fully like starting to work its way out. How is this supported and stuff? We're not sure. And this is what the architects gave Aero, and this was one of their concept renderings, right? We're still at concept, but we need to start to develop it to express some connections. So they were looking at how the form of it, how it could get more fluid. They were looking at the structural, all the stuff we weren't working on. This is all how they start to do structural analysis and understand the behavior of this mesh. But this is the important thing. This is how they were going to start to express these connections, where they were going to keep this lattice as a space frame, and all these connections would go into the sphere. Right? So that right there is something I'll be is what I'm looking for. It's really simple, but it just talks about, this is a general detail of what we're looking for. In fact, it'd be really good if you could just have, like, along with, scripting this on your wall, it'd be also really good just to show this detail as well, to show, like, this is how it's generally going to be connected. They had all these different members that would come into this sphere, and that sphere would and these things would just snap into it and it'll lock in. That's where I'm at. That's where I'm thinking we should be at on next week.
Sounds good.
If this class went further, this is where I would expect everyone would start to look at, is this instance works. Like, the concept of this works, but in reality, it doesn't work all the time. So that's where we script more and get into specific connections then, where in certain instances. So, like, the sphere may grow in certain instances because there's just so many connections. And then we start to look at the angles of it. But really, but this is that skin with all the structural connections to it. And that is what I'm looking for. Not every one of it is solved, but you are showing a connection. You're showing how it's actually going to be, like, where it's actually, okay, we'll have, like, these spheres that hold it up. So that's the level.
Okie dokie.
See, in some instances, like, yeah, it's just, again, it takes the concept to the next level. So, and in this case, they were showing how, and this was it. This is what the guy, this was their sheet that explained the detail. This highly complex structure, roof structure, surface, all its details were expressed with this one sheet. And the interesting thing is that, and these just explain this connection, this sheet is completely useless. They did it because the contract did it. You know, it's the contract documents, right? This is just going through the motions to fulfill the contract. Really, the Excel spreadsheet was the most important document. So, and that was it when it was still being constructed. But that's kind of how I'm seeing this. So, cool. Any more questions on that? Does anyone have any more stuff to show, or?
Well, I actually just wanted to run something conceptually by.
Yeah, go ahead.
Because I think my biggest struggle after last week was like, oh my God, I'm going the wrong direction. I spent all this time and went the wrong direction. I really like the idea of, splitting. So mine was the brain half or whatever. So having two different buildings was kind of like something that kind of, lit some interest in me. And so I didn't really want them to be totally separate though, because a lot of times throughout the year in Richmond, it's raining, windy, cold, sometimes there's snow, but but it's not New York or anything, but it's, you don't really want to go out too much, especially if you're having to go back and forth between the two sections. So my thought was like an atrium, and then there's connections between the two halves through an atrium, maybe different walkways or something like that. And so I actually found a building that I really because I was trying not to do scripts and see what happens, because I did a little bit of that, and just really kind of focus on what the interest was. So I found this building. I'm going to try to share here. Why is it not showing? There we go.
Yeah.
And this is sort of, not exactly, but sort of what I wanted to go with. And I wanted to make sure I was kind of heading in the same direction here. I think this might be a good picture. So instead of them being two separate buildings, they kind of are two separate buildings, but you still have like this, I guess this is the largest atrium in the world or so. Mm-hmm. It's Liza in Beijing. And then really kind of have the connectivity here. So this can be kind of really latticed or see-through, depending on kind of which direction I'd like to go. And then another thought is, and you can't really see here, they have walkways, but I was thinking, so like when you're looking at the Corpus Callosum, it's like a bunch of things coming together to create a bridge. So if you did a good really example where you had a wall and a wall and you had all these different points and they're all kind of coming to the other side. But the thought is, and I haven't successfully played with this yet, but you have one side that goes to just a few points, and then another side that goes to just a few points, but the points coincide to allow a bridge, maybe.
Okay.
I don't know. I want to make sure I'm going in the right direction.
No. I think yeah. I think conceptually, I think we like the idea that it was these two separate things, and it was that slice that was the key, that was the focal point. But yeah, if having those bridging elements could help. Again, I think it goes back to, why the concept works I think is really strong when it's like, okay, that we have these two buildings, but it's like, what's the connection, and why, like if you put a grid, like if you did what Zaha Hadid did, where it's just like this curtain wall grid between it, it's something really simple. I would say why? Why is that grid relevant to your concept? Right? What's the logic that got you to that grid? And that's where I'm thinking. It's like, look at, different structures. If there's is that connection piece in our brain, is that a very stiff, is that very dense organic material? What's its structural pattern? What's its that's the stuff that I would say look deeper into how it's successful. Is it its connection, its ability to connect the two brains together is vital. But why can it do that? Is it the form itself that does it? Is it is there another level? Is there certain cells that do that? It's like that kind of digging it a little deeper to understand that. And maybe it is like this, maybe it is like a very simple grid. And then that just makes more sense now. It's like, oh, well, why'd you pick that grid? Oh, because that's how the cellular structures are, and that's how this is how that thing functions. It's an essential feature that the structure of this membrane is like this, to pass the electrons through it to each side of the brain. It's like, oh, that makes a lot of sense. That just reinforces your concept, make it even stronger.
Okay.
So it's that kind of level.
Okay. I think that's helpful, because I was feeling really lost after the last critique. But
I think you did. It was, I think you had a lot of good. It was just I love the idea of it. I think it was just that one thing that was like, well, is there a little bit more than that?
Another thought, and this is where I get into that, do I need to edit it down a little bit, is, I could still bring in, I could keep, the inside of the building, panel free, and then, open and connected through this, mesh, the way the corpus callosum does. But on the exterior, I could still do some paneling on the exterior potentially. And I just didn't know if that was overkill or if that would be something interesting to explore.
I think it may be, I think it may be really cool just for like the rest of the build, like the two other towers you're saying.
Mm-hmm. Yes, the outside. So I'm just using this as an example. The shape's not the same or anything, but the connections will be different in between. But just the outside shell potentially covered or semi-covered in some of the paneling that I worked on for the first section, potentially.
Yeah. You could totally do that. I think that would be fine. I just keep in mind, like, what's the core aspect of your concept? If it is this membrane, that links the two, and I think that should be the focal point. That should be, the first thing people look at. And then the second thing is the two forms. And the two forms could still be very cool. They don't have to be a grid. They can be something that is very unique, but it's just, there's a hierarchy on how you want to play that off, and how you want to, it's very similar to, like, art. There's a focal point. There's a hierarchy of form to it. So making sure, your concept is going to be the top number one thing, and then after that, everything else kind of falls back to support it.
Okay. And then the last thing, thank you for this feedback. The last thing was, I I kind of like the split in the building being catty corner because it follows the curve. But I just wanted to ask if you would recommend that you go kind of in the center-ish of the actual surface. So I didn't know if that would be more visible of a separation.
I don't know. Do you have it up on your screen?
I mean, I have just the form. I can pull it back up real quick.
Yeah, I'm not sure. I'm not sure which is the best one. That's way, and I guess it's just more of experimenting which one, if it's which way.
Can you see the building? Did I do that right?
Yeah, yeah.
Okay. So, so right now it's on the edge where, I could make it wider. I could have variable edges, this type of thing. Although I will say, the brain's relatively uniform, so something to think about.
Right.
But the other option would be to maybe have it be down the center. It may be more visual that way. It's a lot of work to do that. So, I mean, it doesn't look like a lot of work, but it was a lot of work to do that.
Oh, no, I believe you. I believe you.
So, I just wanted to maybe get your opinion on that before, and like I said, I could make some of the openings a little bit variable to potentially.
I don't know. That's a tough one. That one, it goes back. I mean, that one, that one's kind of like a balance, right? It's a balance between what does your concept tell you, but also what does your taste and gut tell you.
I know it's kind of cool to follow the curve though a little bit.
I agree. I think eliminating the corners and then it becomes more of a surface. It's because corners are very strong, but when you eliminate it, it's just leaves more room for glass. And I think either one could work.
Okay.
If you really want to know, I would just do a quick mock-up, a quick massing mock-up,
Okay.
And don't even apply the script and just be like, all right, what's this look like from, and go from there.
Okay. All right.
I have a question. If our building shape seems to want to be something else, can we change it? Like, I know mine is really twisted, but my panel concept, the Maslow hierarchy of needs, and the way that's more pyramidal, could our building, like in our process, could we show a change in the building shape, or are we married to the original shape of the building?
No, Ruby, I think if it makes more sense to start to untwist yours, especially with yours has a very, very tight twist. So yeah, you can start to ease that. I mean, the thing is, absolutely, you can start to ease it back. And that's a lot of times there's times where we just have to take a step back and remember a lot of these analyses that we do, they don't have aesthetics or function, or actually it's maybe too heavily on function. In some cases, it relies too heavily on function and not aesthetics. So and sometimes it's better to kind of ease it back and make that compromise. Okay, let's make this work a little easier. Okay. Cool. Anyone else? How's everyone's 3D printer working? Doing good? Not breaking down?
Well,
Actually,
I went okay with my modules, but the concept of the building parts and all, I wanted to adjust that. And
yes. So like your spiral, you're saying, on how yeah, you can start to ease it. And yeah, that that would be a very hard thing to construct, and I'm sure a lot of the modules start to overlap and touch each other, and when you apply it. So
The 2-foot by 2-foot physical model that we're supposed to do for the last portion of the assignment, is there a particular scale that you're looking for us to use, or?
it's a scale that as long as we can start to see some detail that's beyond just a concept, that is a scale, and that's why I put 2 feet by 2 feet, and maybe I should have said modules, but I'm not sure how big a lot of people's modules are, but it's large enough that you can express some of the detail that's happening, whether that may be 4 really big modules or it's, you know, a 6 by 6 grid. But it's something that you can express it. If your modules are if the scale, how about this? Because everyone's module is a little different and it's at a different scale. If you could 3D print 4 of them and you can show those connections in between it and how they're worked out, I would do 4 of them, and it can fit within that 2 feet. If it doesn't, if you're a little bit smaller, you can go into like you can do 18 by 18 inches, so maybe it's a 6 by 6 or an 8 by 8 module, each module. So the 2 foot is a loose thing. It's really just, I want to see 4 panels that express their connection to it, that have a little bit, that follow the curve of your building. That's really what I'm looking for. The 2 foot by 2 foot was just a guideline on just making sure that this thing is large enough that we can see some detail to it. We can see the makeup of these panels.
And so if I, let's just say for argument's sake, I decide not to do a panel and I'm doing this grid, what type of printout would you be interested in? Like where the connection is and just kind of like the picture we just saw, like the connectivity piece, or?
If you could show, so with yours, the most important piece is the connection between one side of the brain and the other, right?
Mm-hmm.
So that's where that piece should be cut.
Okay.
So you should see the connection between your module, and you should see a connection of your module A and module B, and then we should see the connection of the glass to it. Does that make sense?
So the connective piece on one side, the connective piece on the other side, and that bridge in between, sort of? Or am I thinking wrong?
I was thinking that would be I think that'd be probably, if it's small enough to fit in that, if you could print it in it. That's the tough thing, because I just want to, it's tough to just say 2 feet because everyone's scale is different.
Oh,
So,
maybe I'll come up with something. That's fine.
okay, as long as the important thing is like, what I'm looking for is the expression of the connections, right? The thought and the design of how these are being connected and are tying back to the building. Or if it's not tying back to the building, it's the actual facade, just like the actual connections of it. Like, is it a sphere, or is it a mullion that holds it all together? You know, it's like, what is it? And that's where, yeah, it's like everyone's scale is different. So it's but just think of, if I can show this to my grandma and my grandma understands it, I guess, that's the scale we should work at. Because yeah, every, like I said, every project's different.
I have a grasshopper question, John.
Yeah, what's up?
Sure. Let me share my screen here. Okay, can you see that?
Yeah.
Okay, so I'm trying to figure out how to incorporate the Ladybug sun feature, and I've got the location data plugged in. And then am I correct by, I'm using this sun vector, and then what I'm doing here is I've got two different faces of the tower labeled so far, and I'm basing this off of the script in the Generative Algorithms book 113. And the way they've done it is they have two different angles that they enter depending on, in this case I have 3 different components, but I'll likely add to that number in the future. And I'm just trying to see if I'm understanding, this part correct, or which of these on the right-hand side column that I'm really utilizing.
Yeah, you mind if I?
Sure.
Because I just want to see the vectors. First, I think that's a big one when your vectors, the output is a null. So that might be one issue, is that you're not, it's either, so the one thing is you need to, so you have your center points and stuff, but you also need to put you have your location, but you also should put your hours of day, because right now it's not sure where to look at.
Okay.
So it's similar to our, to what we've done in the, we can set our hours, we can set our day, we can set our month. That will start to set up the output of this information, because right now it's just saying, what's the location? Yeah, or we're putting into location and they're like, okay, well, that's 12 hours, the default date 21 on the 12th. So it should be, if those defaults are right. And center point, all right, you put the center point there. So it should start to tell us right, because optional analysis period, time step, 1 hour. It's interesting, we're still getting, so it's either might be our EPW file. It goes into open. See, that might be our issue, is our EPW file. Because, yeah, that's a null. So I would double check this connection.
Okay.
Your EPW file. Yeah, because that might be one thing. That's probably a big thing too, if it's getting nulls. So,
Okay.
okay, yeah, I would look into that. But then you should be able to get your values where you can start to change your angles. Now, I remember when I was doing this, these became some wacky numbers. But just keep in mind, like the domain, the domain of the vertex of the sun angle and stuff, and that would really help setting this up and make sure they go in the right position.
Okay.
Cool.
Okay. Thanks.
Yeah, no problem. Let's see if so cool. But yeah, there's there's one thing that another thing I wish we had time to show was generative design. I know we are we're working with generative design, but this is actually a project I'm just working on now, and actually easier if we do this. So right now, what I in this situation, and it's running in the background right now, is we have a project that's going through this simulation, and it's how I set up the script to generate and record every single iteration that's possible for this design. So here's just a few images, but this website called Design Explorer, you essentially upload your Excel file that's created. This website is looking for an Excel file, and it takes that Excel file that's generated from Grasshopper, and it pats out all the possible options for this design. So I was working on this. This is just a little feasibility study I'm working on a project. But it maps out every possibility of all the variables that I've listed and all the outcomes that it has. So in this instance, I have like 7,000 different iterations for this one project.
You can't see your screen.
But the great thing about this is that this is fully interactive. So when you have 7,000 different iterations, actually, I like this one. The one I'm looking at doesn't have 7,000. This one has 250. So when you have that many iterations, it's very difficult to understand, like, how do you even comprehend that, and how do you start to compare which design is better than the other design? So when you put it into this interface, it's much easier to start to understand that. So with this development, we're looking at a feasibility study where, very similar to what we're doing now, but this one's dealing with multifamily housing in units. For me, if I was a developer, we're able to look at this. So we're like, well, right now with this market, I want my units to be on an average of 800 to 750 square foot.
John, are you sharing, or is there something you have on your screen?
Oh, I'm not sharing it. Okay, yeah. Thank you. So, can you guys see this now? Okay, great. So yeah, this is so right now this is a project I'm actually working on, and so I set up the Excel spreadsheet. It created 250 iterations, and this is just I've uploaded the Excel spreadsheet, and this is the website just interpreting the data, and it creates these relationships between all the variables. So these are all the variables and outputs in the algorithm that generates this study. But this is really important because when you have so many of those different iterations, it's like, how do you start to comprehend those and start to make which one's better? So I can start to isolate some of these variables. So remember, these are all the possible outcomes out of this algorithm. So for me, if I was a developer, I'd say, okay, for this market, I want to build something that's 750 to 800 square feet on average. I can go, my maximum height is 58 feet because of zoning, so I'm going to do that. I'm going to cap that out. And see, we start to see the paths mapped out on the possible options that meet that criteria that I'm setting up. So let's say I want the most efficient, let's not even talk about efficiency. So I want to make sure I have 2,000 square feet of commercial. Okay, now I'm starting to narrow down the options that I have, and I can actually start to pick one and I can now, instead of 250, I've isolated it down to 3 different options. So I can start to say, okay, this one's at efficiency of 77%, and okay, and I get my 78 total units. That's pretty good. This one, you know, I'm getting 78. So these are probably all, oh wow, look at this one. This gets me, it gets me 86 units, you know, and we start to understand the possible outcomes I can get for this. And it's like, you know, designing is like walking into a dark room, and the great thing about generative design is when you're designing in that dark room, it gives you a flashlight to know where you're going. Without this, you know, no one has time to manually look and generate 250 different schemes. You know, we're lucky to get maybe 3. But what this does is it gives us a little light in the room so we can know where not to go, and start to validate some of our findings. And a lot of times, especially the experienced architects, you know, they rely on rule of thumb, and sometimes the rule of thumb is not the best way. It may work great in a flat playing field, but in areas where it's difficult and there's a lot of different ways to look at this. This just validates the best findings and make sure we get the highest return out of projects. So in this one, we even had different skin options already that we were talking about. It was more just comparing it to surface area. But no, it was something that we've been messing around with. It's also something very interactive and dynamic that you can start to give to clients, and they could actually be part of the design process. But again, yeah, it's a great little tool that I recommend you guys looking into. It's called Design Explorer. It's usually, I think this is the 2nd version, so when it pops up in Google, it'll say Design Explorer 2. But it's a great little tool. And then you can see all the different options. You can upload it, and all of this is located in a Google Drive that I really just drop the link in there, and it uploads everything.
So this is like when we were getting all our hundreds of modules, that type of thing, or like different, where we run the generative thing. How do you get it out? How do you create the Excel out of that? Is that, I guess we could Google it or something.
I wish I could show you. Actually, hold on, bear with me. Let's see if oh wow.
Oh no, this is when we did the site. The site was the generative, right?
Yes,
Yeah,
actually,
that's right.
my thing is still clicking away.
Okay.
So that's one thing that we got it with it. That's difficult is once the simulation starts, it doesn't stop, and you can't cancel out unless you turn off your machine. And so that was my day. It's kind of babysitting my computer, making sure. So I think it took about 5 hours for it to run through it. But yeah, unfortunately, I can't show you guys because it's all frozen up. But it uses Ladybug. It uses essentially what I do. It's can you guys see this? Like, right? Oh wait, you guys can't. I gotta share my screen. So if I had a box or a rectangle, and it's defined by I'm just going to edit this where just always make sure it's one. That's one. Put it up really quick. We'll get our Z, so it's a box. We'll just put that down quick. And we're just going to cap this so it's solid. Do a little quick volume. So we got so it's like, all right, I want to see all the possibilities I can make out of these sliders. And we want to record it to an Excel spreadsheet. What we do is we're just going to get a concentrate, and we're just going to put plug these in, and I like to just do a little panel that just says, length. Oh, sorry, actually don't. You want a comma, because we're going to call it, it's not really an Excel spreadsheet, it's a CSV file, which is, I'll explain that in a little bit, but Excel spreadsheet reads it all. It's a spreadsheet. It's just a different way of it. Just that, we'll put that. So our output, we'll add the volume to this too. So it's really important to put the commas there, because the comma, a CSV file is a spreadsheet that breaks up the information into different columns based off columns, the comma location. So the way the spreadsheet's worked out, it's going to be a 10. 10 is going to be in one column. 10 is going to be in another column. This other 10 is going to be a column, and 1,000 is going to be in a column. So then Ladybug has a great command called fly, which you input all your sliders into it. Boolean toggle, because it's looking for that. So fly, what it's going to do is it's going to run through every single iteration of this. Right? So if we click true, it's going to be like, oh, hold up, we're going to go through 1,000 iterations for this. Maybe we just make this 5. we make all that 5 really quick. So it's just a little easier. All right, so it's going through 125 iterations. You're like, sure. And see, it just goes through every little single iterations of this. Right, so nothing so far has been recorded yet. This is just showing fly that, yeah, it goes through everything. It's okay, we did it, and we did it in 24 seconds. So we want to record all that information into an Excel spreadsheet. So there's a component called data recorder. It records the data over time. I'm going to actually show this as a panel. So we have that. So the tough thing with the panel, right, is when we change our slider, right, it just replaces one for one. But we don't want to replace it for one. We actually want to record all that information that's being generated. So that's where we grab the data recorder. Plug that in. So now when we change it, it keeps that information in the panel. Now it's really important if you want to clear it. You know, you can set your limits to it. I actually just delete it. If you delete the panel, you didn't delete the data, right? So the data's still there because it retains it all. So we have that. We're gonna run through our iterations again. So it goes through all of them, but this time the panel is set to a data recorder, so it records all of that information. So it records the length, the width, and the height. So here it is. So then we're going to right click on it and we're going to stream contents. We're going to get a little file that pops up. I'm just going to save it on my desktop. And we want to save it as a CSV, comma separated value file. Just say on my desktop. Box example. And there it is. It should be 125, 126 of them, all possible options in our Excel spreadsheet. And then we can always edit this, like for the Design Explorer, they require certain annotations for the top so the data can be read and separated. And so yeah, it's pretty sweet. You can also, along with that, you can also save all these screenshots as well. So you can also do Ladybug has Ladybug view capture. And what this does is anytime a variable changes, it takes a picture. It snaps the view of a certain view that we specify. So if you say perspective, captures that. And I set it up so it can, while it's going through all the iterations, it will save an image, and then it's formatted to an Excel spreadsheet. So it does all that at the same time and runs through it. So it's just another way that you can start to automate all your tasks. So that's why my computer's bogged down right now, because it's going through 5,000 iterations. And so you can start to see start to see some of it, or it'll save it, it'll change it, it'll save it, it'll change it. Because it's just testing all the different unit possibilities that can fit within this and trying to find, and then later on I can put it into Design Explorer and see them, what's the unit that I can fit the most in. So, but yeah, it's something, that was another thing that is pretty sweet that we can hopefully, ways as we can find time. But, great. Any other questions?
John, I actually have a couple of questions actually.
Yeah.
So I'm kind of reevaluating how I'm doing my thing, and actually kind of changing direction a little bit. And one of the things I'm trying to figure out is, I know you can extract a surface, I know that you can actually get a lot of the information. What I don't know is like how our buildings twist, right? How do you get that edge? Just one edge. Like, I know you can get the whole face, but how do you get just the edge? And
Just
treat
one?
it like a curve. Yes.
Um,
I'm not sure what that variable is. I know I can get edges, but how do you distill down to the edge that you want? So like if you took a B-rep and you did the B-rep edge thing, right? You get the kind of the naked, the interior, the non-manifolded, but it's a lot of information, and I'm not sure how to get the one, I guess.
Is it just that one edge that goes?
I just want the one
side?
sweeping edge, yes. Yes. Is there any way to grab that?
Yes.
I just haven't been able to figure out how to do it. I can get the face and I can put a grid on the face the way I want to, but I want just that edge so I can kind of control how I want the shape. I know it's kind of a pain, but
I'm sure there's a plugin. I know there's something that is like you can extract the boundary of.
Yeah, you can get the boundary surface, you can get the frame, but I don't know how to get just the one edge. It's the problem from, even if I get the frame, which I can get, through a surface frame or even divide the surface, you can get some of the points, but you can't get the whole curve.
So, just so I'm understanding you correctly, we're looking for not all these individual panels.
No.
We're looking for like that edge right there. Correct?
Yeah.
So
after it's been a B-rep, right?
After, yeah. So let me change my. We get our surface. Actually, we're not going to make it a surface. We're going to get it as a B-rep. Let me think. So we have our B-rep surface. If we connect it to a curve, now this is one of the few exceptions in Grasshopper, but if you connect a B-rep to a curve component, it takes a wireframe of your surface.
Right.
So then you can explode that. And then we can do our list item.
Just do
And, you know, there's 4 sides
it. Okay.
in our curve. And we now have 4, we have all 4 of our curves into separate segments.
Okay.
So
Was
then,
it
yeah.
sure? Yeah, okay. That makes sense. Because I was trying to figure out how to use the item. I just wasn't sure how to get it to the curve, I guess.
That I said, I think this is the only time this thing kind of breaks the rules, where it actually takes a parameter and it converts it into something else by like a B-rep and a surface is, you know, there's a lot of similarities and they can blend together. But like actually plugging in a parameter into a parameter and getting a different output is, I think this is one of the special occasions or exceptions. But yeah, that's how you can isolate that curve. Get that.
Okay, that's the part that I was missing. So, okay, that makes total sense. All right, and then my other kind of dumb question, I know you went over this early on, but controlling layering with some of the shapes and surfaces. Is there a way to do that?
Wait, I'm sorry.
As you're, segregating your material or segregating your like your extrusions, your curves onto different layers so that you can control them. Is there a way to do that?
I'm still having a tough time understanding. So
like you build your script, and without doing all your swatches and everything, by the end you have kind of a shape, right? But you want to control, like you have two different shapes that you can kind of merge. And I can share my screen to show you.
Yeah. Can you share your screen?
All right, so what I'm talking about is I want to be able to have this surface as one layer and this surface as another layer.
Oh, and then
Is there a way to do that?
so and you want it on separate layers for Rhino, not in Grasshopper, right?
Correct. Yeah.
Yeah, there is. So once you have them separated, right?
They are separated, yes. And that's those 2 extrusions right here.
Go into the do you have the lunch box? Yeah, I see the lunch box.
Yeah.
Go into workflow. The far right, yeah.
Okay.
There should be
layer information and layer reference.
Layer reference,
or create layers.
Try create layers. See what happens. Create toggle. Okay, maybe that's not it. Maybe it's not. Let me look in mine really quick. And mine, I don't have too many on this one. It might be. It's a. Yes, you can do it. It is. However, I don't believe it's in the base of Grasshopper. It is it's a plugin, and I believe it is. And I just want to double check that it's not in. It's not in anything that I have right now. Wait, object Sorry, it is in Lunchbox. It's called Object Bake. So yeah, it's under Object Bake. That will specify, you know, your objects, what layer you want it on. You can even assign it a name in the properties, the color and stuff. That can help. If that one doesn't, I believe there's a more advanced one called yeah, if you I'm gonna share my screen really quick. If you use Ella Front, if you guys watch that documentary, Front was the firm that collaborated with Zaha Hadid. So all this stuff is like if you're big into fabrication and CNC machines and stuff like that, and using Grasshopper to do that, this is like your best friend. This plugin is, because you can bake. I believe you can bake things. You can assign it to layers. You can automate dimensionings, and it does all that stuff. I believe that's another really good one that helps out.
Is that in the Food for Rhino? Or is that...
Yeah, that's Food for Rhino.
Okay.
I believe that has one that does the same thing. I want to make sure it's. I think Elephant. The other one is Sasquatch, but that's another one that might have it. But my guts tell me this is the one that has most of the stuff in it. But yeah, if that bake doesn't work, that may be another option.
Okay, thank you.
So, cool. All right. Any other questions? Well, great, guys. I'm looking forward to next week. And again, if you have any questions, let me know. Shoot me an email. I apologize for a lot of the delayed emails. I've for some odd reason, they're not going to my ltu.edu. So if you email me on Canvas, it won't notify me on my LTU. So I get only half of them. And then, so if you could just email me to the LTU one, that I'd be a little more receptive on that one and try to reply faster. But yeah, let me know if you have any questions or have any help. We can always do office hours too, and do another Q&A sessions. I hope that's helping everyone out. But yeah, just let me know if you need anything. We'll keep chugging away. I'll send more information shortly about. Well, actually, review 3 will be following the similar format as all the other ones. So we might have a few more people. I'm not exactly sure. I know Eric, and I'm going to see if Jason can join us again. I'm not sure if we'll have some other people might join that. We'll see. So great. Thanks, everyone. And yeah, let me know if you need anything.
Thanks, Aaron.
Yeah, no problem.
Thanks.
Okay.
Hey, Troy, how's it going?
Hey. Now I have something put together, but I feel like it's not following my concept at all. This is kind of where I'm at.
Okay.
When you zoom in on it, it looks more like DNA in metaphase than it looks like muscle fibers. It's lost that irregular, elongated texture when I try and turn things around to get it to line up. Instead, it just starts looking really not good. And then I also need to plug in the daylight components to get it to factor for daylight. And I only have 2 sides showing right now. And it's still, if I make changes to the number in the script or anything like that, it really starts to bog things down again. So I'm not sure what to do to make this work better or get it more to the concept, or if I just change my concept.
Well, I think let's stick to this concept. I think we can get this to work. So do you want it to twist like that? Like it looks like one top part is flipped, like one's going 1, 2, 3, 4, 5, and the other one's going 1, 2, 3, 4, 5, the opposite way.
What I did is I did reverse it to try and have the fibers run in 2 different directions, because muscle fibers, they do have like a thickness to them in the middle, and then it gets thinner towards the ends. And then, you know, when you pack them all together, the fibers together to make the muscle body, those are lining up irregularly. So it gives you this kind of staggered effect of the larger cell body or fiber body with the elongations to it.
Yeah, let's keep taking further. Yeah, let's see what's going on with the script. Yeah, it seems.
The other issue that I have is when the tower is on, it gets sucked inside. So I also need to offset it so that it sits in a way that's visible.
Mm-hmm. Yeah, so you have to offset that. So what makes up these are they these pipes, are they different sizes, or are they?
So it's the lines, which are right here with the different counts and the different steps. So when you're in closer, you can kind of see how it elongates and tapers out to a point, but then it builds into that belly and then thins out again.
Okay. So when you have that little twist like that with the muscle fibers,
I would rather not have that, but when I've tried to get it to flatten out, it leaves even bigger holes and openings. So it hasn't, I don't know if I just have the counts wrong or if I'm putting things in incorrectly, but it basically makes gigantic openings instead of just kind of the nice fibrous style that I had with the wrong thing on the Voronoi.
Yeah, that's because it's, I request control really quick, because that's one thing. Yeah, it feels very panelized.
Yeah, and it definitely has lost a lot of that organic feel that it had.
So one thing, so let's first look at this script too, because there's other ways that we can start to make this a little more organic. All right, so you have your massing model. We deconstructed it. You have sides here. Okay, so that's one side. That's cool. And then you got your surface, and then you divide the domain up. We have our curve. Okay. So I don't think we need, right? We got.
Right now, there's nothing coming from that, so I don't know if it's even needed.
Yeah, so maybe we just need, and with these, you know, that's. Right, so all right, so then let's maybe we don't need, so that those curves, that's cool. So one thing it might be, what is this? Points, divide curve segment, divide each segment of curve into each.
So that's what I have for all the points on the lines. So the U and V lines.
So if we jump this down to like 5.
It does spread things out, and then I get those larger holes again.
Got it.
And then my grasshopper takes a hot minute, and I usually have to go and reopen it from Rhino.
And there were, I think we might, I see this super large number. This might be one. Okay, so it does it like that. What's this one? Smaller than.
So the super large number is because the point is behind that triangular building. So like the point that it's referencing distance to, it was
Okay.
over there. And then that's where it's setting up that variable for how it's crossing those lines.
Okay. So then you had your curve. We did a perpendicular frame to it. And then, okay, so then you did a series.
And that's what makes the circles either larger or smaller.
Okay, so how many circles are we? So there's 400. So we do have some extra surface circles. We're getting a little bit of an error here. That might be because there's 7 circles. Let's see if this works. So this will help reduce it, because I think the default is 10. Okay, I didn't do anything.
So when I adjust those numbers, it adjusts the number of frames.
Yeah.
So you see those lines there, that's what that has been adjusting. I find if I put it over 7, it turns it into more of a cone shape than that pinched, then like open kind of bulbous tulip shape.
Got it. So then we do our circles. All right, so those are all our circles that we have. And then we loft them all.
Mm-hmm.
And we get invalid profile. Okay, something's happening.
And I think that is why it's pushing it into the tower itself instead of it like gliding over the surface. It's actually pushing it into the surface, which is why I was thinking I need to loft it.
Okay. So there's a few things that we can do. Also, so that's one side,
And that's side 2.
and that's side 2.
Yeah. So 1 and then side 2 is down below it.
Okay. And maybe we try. Have we tried just a simple divide curve on this? Has that been work? Have you tried just a simple divide curve?
I didn't do that.
Maybe that might help. See if this works. Distance per point. This might help it run a little faster. All right, so there's that. Let's see. See if we can. How many curves are that? Should be okay. All right. So they're the same thing. So that's fine. We'll just keep it what you had then. Just a different way you divide it up. Instead of so there's two things. What we can get this thing really organic looking pretty quickly, I think. But the trick is we have to break that frame up, right? Because that frame is kind of screwing things up. It makes it feel really rigid, right? It makes it so it's not this organic flow that goes up.
Because I tried doing just like one section instead of 3 across, and I ended up with basically just this giant hole with one single swatch of bundled up fibers.
Okay. So.
And it ran vertically, straight up and down when I took out the 11 different sections instead of following the curve. It just straight line right up.
Where's Grasshopper? Why is it not popping up? Is it up on do you have another screen?
No. This happens to me every now and again.
So
So like those I set with the UV sliders at the beginning.
Mm-hmm. Change this up really quick, and I'm going to delete this loft, and also we're just going to make that a little faster. So by turning off a few things, that could help a lot. And not having it in 3D yet.
Like the panels I just had in, because that gave me the distances so I could find out like what to put that slider number at, where it's at like 883.
Okay. So the big thing is we can have these bunch up like that. That's fine. It's actually how the continuity between these are troubling, is the thing that's troubling me. Right? Because I want these to be the same. So that's where, you know, what I'm thinking is it's almost like these have, it's like there's all these extra circles there, or one ends at a different diameter than one begins, so there's not this flow that we want. So that's where you got to be a little careful on how that's, yeah, where there's like, it looks like maybe there's an extra one there.
And that probably has to do with the fact that the, if you go over further on the script, the sliders are different for the step. Oh, no, I do have them the same, but the count is different.
Yeah, that might, that, so if we did, count, and we did the frames the same. Let's see what. Oh. Let's see. Yeah, so now we're starting to get a little better. So that helps a lot right there. So those should be, so oh, it's interesting that the circle,
It's towards the bottom of the tower because of that distance.
Got it. Okay. So I wonder if now, how are these organized right now? Invalid circle. So it looks like there's an invalid circle on each one. Okay, but that shouldn't be too much of an issue because it's still lofted it. Something when let's grab our loft. And so we have our series. So do we want the step to be, and we want the steps to be the same, right?
Mm-hmm.
So we're just going to plug that in just to get, so we know they're all on the same page. So that's reverse it. I think if we loft it, see what happens. All right, we're gonna flatten it. Do we need to flatten it? We'll keep that there, just like what you had earlier. What I'm curious is the thing that's troubling me when we talk about conceptually that organic flow of it is how just, you said rigid it is. And that's where, do we just join these two? Well, that's the one thing is, I guess, what conceptually, like, what is it doing? I guess, hold on, maybe before we get into that, I'm just curious, can we get rid of this organic or make this more organic and just join all these surfaces? Join curves, join. Can we start to join all these together? And then I'm just going to make sure those are always turned off. Mesh it. See what happens if we do this. And we'll just do a weaver bird to it. See how it functions. See if it can't get a little more organic. Anything this may crash. So what I'm trying to do is, you know, we have such those stark connections, such a harsh connection there.
Mm-hmm.
But if we can join them together, and then we can weaver bird it, and then now it becomes, instead of your shape becoming this, it's becoming more like an hourglass that runs up and along it. That becomes a little more like the tissue that you've been talking about.
Yeah.
And then you can adjust those parameters if like the tissue thickens up in certain areas or it can relax in certain areas.
Okay.
I think you're on the right track. I think it's just the key thing is you're really not doing a whole lot to make it like there's not too much craziness that's happening why it's slowing your computer down so much. So when working on it, I think we have it up. All right. I think reducing this down to 5, maybe this down to 2. So it's a little more manageable.
Mm-hmm.
So if you're still having computer issues, it's just you gotta reduce the resolution of things.
Okay. When you look at this one, with how it is, you can see like there's a giant hole underneath, kind of right underneath that first one on the right. And that's the issue I kept running into. I kept getting these gigantic open spaces that it kind of defeated that organic feel that I was going for, and for like that layered tissue, because the muscle cells that work or combine to make the muscle fibers, they're interlaced pretty closely. There's a little bit of like fluid around them, so there needs to be a little bit of expansion room, but for the most part they're packed in pretty tightly. And unfortunately, the way it's looking right now is it's very open and loose, which is part of why I had the breakdown higher. Also because it followed that curve a little bit more of the structure, but then you know, it still was that issue of it looking far too rigid instead of being that flowing curve like I had when I had the Voronoi over it.
Right, right. I think first, it might be good just to unplug the dispatch, you know, since we're still just kind of form finding right now.
Mm-hmm.
Turn that off so we can start to start to understand this more, because while we're kind of testing this out, why like this big hole is here, I don't know if it's because of the dispatch or
It has to do with the smaller then, because when the panel was attached to the distance, like it gave a lot of the full listing of numbers, and it ran everywhere from like 1100 down to like 580. So like the average summation was somewhere in the 800s, so that's why I set that slider at 883. But that still left me with that giant hole.
Okay. So I think the first thing, I think this is going in a better direction than your concepts, and I think we're getting there. I think there's just a few things. I think first we should probably turn off the dispatch right now. Let's hold off on the behavior right now. Let's just make sure we can get this model that's similar to your concept.
And I have it. Let's see.
Okay, if you have a different one, that's perfect. So then
Yeah,
once you have that, the second thing is, okay, it's you know, it's still pretty rigid and not following exactly what we want it to do. I think a good option to start looking into is the Weaverbird.
Okay.
And the important thing is that from that, because I want those pipes. We could actually, there might be a better way to do that. Because what I'm thinking is we want those pipes to hourglass along, like have some kind of tone to it that's a little more organic, that runs up and down your building. So that's an important thing to keep in mind.
Okay.
Another one is, then once we modeled it, then we can see how that works out. In fact, you don't mind if I share something really quick?
Sure.
I think it's actually very, very similar to this. To this thing. This aside. We're going to just get this set up really quick. just going to get a just want to get a quick form really generate it really quick. There we go. All right, so we have this form. Right, and so instead of, I wonder if it's treat everything. So you explode that and you have your segments. Just take all these and we're just gonna and actually we're gonna dispatch. Just gonna merge these together. And what I'm doing is I'm just gonna take these and I'm doing exactly what you were thinking of just do these things flip flop. And I'm just doing it a different way instead of that. So we have, you know, oh, oops, gotta flatten this. There we go. So, sorry, so we have these alternating curves. And we can divide, we can just divide them up by, we'll just say 5 right now, just for, just have these up as 5. And then we're going to reverse list. And so if we have these here, so now we're trying to do is if we have all our points here, this might not work. So we have these points, and we have these points that are reversed. It's almost like we want these lines to jump to each other. Maybe that's not the way to do it. Maybe there's a different way to do this. But what I'm thinking, what I'm trying to do is similar to what you're doing. It's just maybe it's a different way. And maybe it's a little easier on your machine, where it's just where it can just draw a line that follows all the way up. And maybe it is just this. Just bypass all this and just delete this. I should just go right. I should just go flat. We want this to be grab this. This actually should work. So it should be 4 of that. Divide. Did that work? Do I need to get rid of this D? Fine. What I'm trying to do is so we can get that curve that goes all the way up here.
Okay.
Half map, but it's a little finicky. Oh, we don't want to get rid of that E. A, B, C, D, E. So maybe it is take. See if this works. No. Maybe that's shoot. Sorry, this is but I think but I think what I'm trying to do is just think of a different way to a simpler way, and maybe I'm just overthinking it, but I think you got a good start on what you're doing. It's just trying to make it more organic, like the tissues that you have and all that. It starts with the corners.
Yeah, because like what I have as the panel itself, it's a little irregular and has the openings, but the rotation came in
Oh yeah.
here, and that basically just put the more bulbous end at the top and it narrowed at the bottom, whereas on the other one it starts at the bottom and goes up to the top. So like this was kind of, you know, the basis or the idea of it. And in this case, if it does have those openings, I would be okay with it because it still has enough to it where it's layered over itself, but it doesn't have that hard twist within that diamond shape opening in it And I think I could even just adjust the curve on this to change it out a bit more if I really wanted to.
Hold on, just a sec. I'm sorry.
Uh-huh.
Okay, sorry about that. So, okay, so it starts to have that little bulbous end to it.
Yeah.
Okay. No, I think that, and if that, I mean, that works for, I mean, it goes similar to your concept, and yeah, that seems to work. It's just those ends, you just are getting a lot of extra count along those ends there. So,
Right
so
down
it's,
here.
yeah. So as long as you're able to fix those, it's more of just it's just making sure those counts work with each other, so you're not getting that. Or unless you want this little peak at the end, so it's like maybe it's it winds up to a sharp point and it peels back down. So maybe that could be it too.
Yeah, because on the opposite end, it does come to that really fine, sharp point, but
Yeah, and I would try to avoid the sharp points because that's in reality it's never going to get that sharp. So always make sure it has some kind of thickness. Also, if you're going to 3D print it, it's not going to turn out because it's just infinitely thin. So keep that in mind as well.
yeah, the issue is when I do go smaller, I get that twist just further down, and when I go larger, this turns super thick, and it does come down still to that super fine point.
So that's dealing with the numbers, and it's also dealing with your series. So what's your starting point for your series? So look at your series. So it should be
1.125.
But that's the increment, right? It goes up so look at the S though.
I don't have anything plugged in there.
Right, so it starts at 0. So that's why it's so small.
Okay.
So have that start to, maybe that's at a number. Also, if you're going to 3D print this on a larger, if you're going to print this on a smaller scale, it's going to be tough to print some of that stuff. So just keep that in mind. And maybe, don't worry about that. That's 3D printing. That's more of like showcasing the concept than the actual concept. But yeah, keep that in mind because that will add that extra thickness at the bottom. So okay, so it's starting to get pretty organic like that.
Yeah.
And same with your other series. That's why the other parts like you're tapering really down. There we go. And that's and you're getting those extra circles there just because you have more in your count. Your count is 10, while you're only providing 7 frames for it to reference. So you may only have, you're going to have 7 frames, but you're creating 10 circles, so you're getting extra circles.
Okay.
So
still have that extra.
Yes. So you're going to have to connect that 7.
Uh-huh.
to your C in your series.
Got it. Okay.
So now so you don't get that extra circle now. So now, it's more of just playing with the increments of how you want it to grow, stuff like that.
Okay. Got it.
It's still getting a little.
It's looking more just like a tube or a straw, and it's kind of
Right.
lost that bulbous portion.
So then I would just take it back then, and so then maybe, okay, we add extra counts to that so it can start to get that bulbous action to it.
Okay.
So yeah, it's just more messing around with that, but then thinking about how the two are going to connect. And that's where, because if you did this on just a panel and then you copy that panel up and copy that panel up, these will never connect properly because it's going to be a pipe, pretty much a pipe and a pipe, and you're not going to connect. So that's why everything should be through the lines first. So you have all your lines, you get the behavior of your lines that you want and the subdivision and stuff, and then you join them all together. So all the vertical ones should be joined going up, and then you do your P frames, and then you add your circles and stuff like that.
Okay, so these should all be joined first. So this stuff here.
Well, in this scenario, it won't work because you don't have any up top or bottom. But yes, they all should be joined so they work well to each other from top and bottom.
Okay. So it'd be putting a join block. Something like this in around here for these.
Yes, that should work. Now we'll see how it goes because we have to understand how the data tree is put together on your tower.
Okay.
But that might help.
Okay.
I'm trying to think. Also, I would look into thinking that data mapper might help a lot. That would help a lot. But
I mean, I downloaded basically everything. So if there's something, from Pufferfish that would work or any of the other ones, I have all of it.
Okay. No, it's more of it's more. I mean, that's the tough. It's more of understanding the behavior of what do you want this thing to do, right? That's part of the art about it is what's the logic of this behavior, and then being able to script it. So it's like the first challenge is just understanding what are the relationships. It's going to be, this line is going to be, I want all these pipes and I want them to grow in a bulbous way. okay, well, where do they bulb out? When, is it something that's gradual and it dips down, or is it something very sudden? Okay, how do we even get that? Okay, well, it's controlled through a line and a point. Okay, what's the behavior? Is the line gonna like segment all the way up to the top of the building? Okay, so how are we gonna do that? Is the line gonna be segmented, or is it gonna be a smooth line? If it's gonna be a smooth line, all right, so that may be a different logic. It's like that kind of stuff, okay? And it's like, okay, where does it bulb out at? Okay, does it bulb out at certain parts? Okay, at what areas? Is it the floor areas or at every floor level? It starts to bulb out. It's that kind of logic that would really help this understand it, because right now we're still a little, I feel like I'm still flying a little bit blind and just understanding what exactly do you want it to do, right?
Okay.
It's like, what's the first, does it taper in and out? Okay, it can, but what's it going to do for the rest of the skin? And that's where we got to start to think about that.
Okay. So, like, I'm just kind of messing around with this here. But, like, I don't know if this is something that even works. Just to try and get, like, those center circles to change out. I don't think this is going to work. So what I was trying to do is change the radius of just the middle circle instead of, say,
Just get the middle circle to be bigger.
yeah. Because it takes that all the way down.
So yeah, for that, it's almost to get that's for it to be, that's where it's like, well, does it bulb out and make it bigger? Well, why does it do that, and where does it do that? Are we doing it in between the levels, or does it make more sense to do it at the levels, or like at the floor levels, right?
Mm-hmm.
So that's where it's like, maybe like the way you did it right now, it starts small and tapers up. Well,
Yep.
That makes a lot of sense where it does it at every floor level. And then the next one up can be the reverse of it. That's another way we can do it.
Okay.
And all that, and that could just be a panel right there, right? Is just a tapering, like this could just be a very simple line with radiuses that go up, and that's your panel. And then you subdivide your surface a lot, so you can get a lot of them on there. And the radius of the circles can change based off, the sun or the wind or whatever you need it to be.
Okay.
But I think you're onto something. I think we need to just fully understand what it's doing, and simplify it. I think it's that's where it's like, maybe just think of just one little rod, and that's your panel, or one tapering rod, and that's your panel, and we can always flip it or rotate it any way we need to.
Okay. So basically, get rid of this portion or this portion here, and just focus on one of those units.
Yeah, that is your unit. It's just this fiber, that one little fiber, and does it taper up and does it taper down?
Okay.
and then we can put that, and that's your module, and then we can get that, and we can reverse that, right? Because you can, on the Q&A, I've showed how we can subdivide that surface into two. So we could always, we have one that tapers from small to big, and then the top of it, it can go from big to small. And we have those two modules, and the tapering is all based off sun or structure or whatever we need fit right now.
Okay. So focus on just this. So basically cut out a lot of this back here. Focus on adjusting the diameter of, or the radius, the length of the radius on these, and then worry about getting it towards 3D.
Yeah. I think that might be the best way.
Okay. Got it.
Cool. And then we can adjust how the behavior of it. And that's just a module that'll follow all our other stuff. So I think that will help.
Okay.
Do you feel pretty good about that?
I feel a little better. I'm still trying to process what scripts I'm going to have to use to work with that radius of the circle, but I think I have a better idea. Do you know when you're going to be doing the Q&A session again, or if you will?
Yeah, I can do that. I can do that Thursday. I can do that Thursday.
Sure.
I can send out an email.
Okay.
And we can get this going.
Okay.
Like, continue to work on it. Don't, please do not just wait till Thursday.
No, I want to try and get at least the rod segment figured out, to get that part locked in so that I can then expand on it. Because I've already lost too much time for 3D printing, and I'm getting a little nervous about that.
Okay. Yeah, just okay. So, all right, no, but I think this will help simplify things a lot.
Okay.
So.
Okay. Sounds
All right.
good.
Cool.
Thank
All right.
you.
Yeah, no problem. I'll talk to you Thursday.
All right. Sounds good.
All right. Cool.
Thanks.
Bye.
Bye.